Hello everyone, today we'll talk about the solution to the problem count sub-islands. So the prerequisite of course is the standard counting islands problem, where we have a grid of land and water and we have to count the number of islands, and islands are of course four connected, so connected horizontally or vertically, groups of land tiles. The solution there is very simple. The easiest probably one is to just use any graph search, for instance DFS. So we start with any land tile that was not visited yet, we visit all the neighbors that are land tiles, and they are all a single island. But in this case, we have this twist where we want to count the number of islands in the second grid that are sub-islands of some island on the first grid. So we only want to count an island in grid 2 if there exists an island in grid 1 that contains all of that grid 2 island and maybe some more land. So when you think about it, how this situation can look, you for instance can easily notice that if there is a position at grid 2 where there is land, but at grid 1 there is water, then that whole island that contains this land tile in grid 2 cannot be a sub-island of anything. So in particular, we want every tile that has land in grid 2 to have land in grid 1, or at least any tile of a given island in grid 2 to have land in grid 1. And in that case, we know that it's simply a sub-island of some big island in grid 1. And this is the only thing that we need to check. So we need to check for every island in grid 2 that it contains only land tiles when we look at grid 1, and in that case we know that all those land tiles will be connected because they are we know that they are part of the same island in grid 2, so they have to be the same island in grid 1 as well. And in that case, we get the correct sub-island. Otherwise, there is at least one water tile, and in that case, of course, there is no island that contains every tile from the given island in grid 2. So we have the standard boilerplate, height and width, taken from the grid, and directions we can go in to see the neighbors. Res will hold the number of islands, so we'll return it at the end. And we go through every possible starting point, but we only start at positions that are land positions. And in order to mark different positions, we'll just make sure that we sync the land tile as we visit it. So at first we assume that the island is correct. We will mark OK as false if we see some water tile from grid 1, where we have a land tile in grid 2. And we start at that row and column, and while we have something, so we use a stack here, so this is a DFS. If this was a queue, it would of course be a BFS. We take the next tile. We see if grid 1 on that position is land, so we just end this OK variable with the value at grid 1. This is the same as multiplication in this case. Any 0 that we encounter, we have to make sure that makes our OK a 0. So it's just end of all those, or a product of all those. And we go in all four directions. We calculate the new row, new column, and if it's within bounds, and it consists of a land tile, we mark it as a water tile to not visit again, append it to the stack. And at the end, if our OK variable is still true, we have found a new sub-island, and we can add it to the result.